shall we say, a tennis court or whatever, and we're shooting some levels. Now, just to be perfectly clear, if we were doing a tennis court or an area for people to sit outside and have coffees or whatever, we generally would be just looking at the very top surface in terms of repaving or something like that. So, and we'd be levelling it out perfectly for drainage and that sort of thing. So we wouldn't really be doing a design on a tennis court and getting very concerned about the cut and the fill on that side of things. But, you know, bitumen costs money. Whatever you're going to put there, the surface costs money as well. So, you know, it's an engineering job that we would have to look closely at the levels. With this, the exercise that's following on from my lecture on Wednesday, I would like you to do contours, what does it say down the bottom, every half a metre. Okay, so looking at it, can anyone see a good place to start? 53, there's also a 54 over there as well. Okay, so obviously you haven't been talking to the previous class because the previous class was offered a half a mark for the best place to start from. And obviously you guys have forgotten everything from last semester because the golden rule of AutoCAD before you start is to make a layer. Okay, so we always start by making a layer. So let's make a layer up. Yeah, there was 2 or 3 students in the last class who weren't very happy with my way around that one. So I'm going to make a layer up and call it contours. Don't worry, I've got a few more of those tricks up my sleeve. Wait till next week. So I'm going to get you started, and guess what? I'm going to make you do a bit of work after that. So it's probably a good idea to just put this on here, take off all these settings, whatever they're on at the moment, and just put nearest on. That way it doesn't bounce to different parts. Now remember, this is eyeballing, guesstimate I call it. So it's best to do a P-line, and basically 53 is the next best. Now see that stuff that's following me around? I call that bubble and squeak because I hate it. It follows you around all the time. I don't know what Ingrid told you to do, but I always change my snap settings down here to dynamic input and get rid of that lot. I see so many students that have that bubble and squeak going on, and they're trying to ask me a question, and these numbers are popping up all over the place, and I'm like, whoa, stop, get rid of that. Okay, so a little wee tip there. P-line, shortcut, PL, enter, or if you've got AutoCAD Classic already set, you can click on it as well. Notice that the standard setting doesn't have it does have a polygon up the top corner, beg your pardon. So I'm going to click there. I'm now going to estimate between here and here. 53 is real close to 0.91, and it's a long way from 53.62, so it's probably somewhere around about there. Looking between these two, well, it's definitely not going to be between these two or those two, so it's probably going to be somewhere around about there. It's a bit closer to the 80. Notice that one's 54, not 53, so it's probably closer down here, and then back to the 53 over there. All right. So that was fairly painless. What I'd like you to do is do the guesstimate yourself. I'll give you 3 minutes, 4 minutes, and we'll make it 5 minutes, and then I'll draw it in 3 seconds. How's that? Good deal? Have a go.
key line.
The person that said 54, that's probably quite a good next place to start, actually. 54. Meanwhile, okay. So you'd start at 54, but it's a little bit different. You're going to have to guesstimate it coming through here somewhere. Then it goes back up here somewhere, and then it's going to go up here, and then there, and then up here. So the 54 line does a little bit of a strange thing like that, but I did say that I would draw this up in 3 seconds, didn't I? Which was a bit of a smart thing to say, but what I forgot to tell you was I've already pre-drawn it. So when we go to our layer management and turn on the answer, you'll find it is there, okay? And let's have a look at what I've done. I'm not quite right, but it was pretty good for a guesstimate, all right? So what I did was I drew the 53, then the 54, and then I put the 53.5 in the middle of the two, all right? So that's the kind of last of our guesstimate. So you can see that you can still do a pretty good job of your contours, guesstimating, right? And for a lot of site engineers, that's perfect. That's all they really want to do to give them an idea of what they're trying to build. Let's face it, nothing in a civil engineering site is going to be 100% perfect. There's always a little bit of tolerance on what you're doing. Structural's different. If structural engineering's your passion, you know, let's take steel beams meeting steel columns, and you're bolting a plate on somewhere, and you've got a hole that big to put the bolts through. It's got to match. You know, it's no use being 10 mils out because you're not going to get the bolt through, are you? You know what I mean? So structural's very, very different. We do that a lot more precisely. and I'll be giving you some details on structural bolting and that sort of thing in terms of working out the holes for things, etc. But in civil it's a little bit different. So as a civil site engineer, you're going to have to do a lot of this type of stuff manually. It's doubtful if you'll have 12D, and it's even more doubtful if you'll have a copy of AutoCAD, and you're more likely going to get a PDF file sent to site, which you'll print on a funny old printer that's there. You usually got the worst printer on the site, because they don't want it getting all dusty and dirty. And then from that printing, you might have to do some contours to work out what you're going to build, and to show the digger driver and the truck driver, hey, this is what we want to end up with: some mounds over there, some bunds over there, and some sort of a silt trap pond over there, right? But you've worked the contours out because you've had them sent through to you as spot heights or half contours. Now we go to the next part of design, which is rather difficult for some people to flip from a plan view to a sideways view, which is kind of going back a little bit to technical literacy on those first few weeks, where we were trying to get you to do elevations and sections and the plan view, and we were flipping that block around, having a look at it. So in civil engineering, when we do roading or we do platforms, it's doubtful if we're going to get a site where we can put a platform exactly on top of the same levels as the ground is. Normally we're either cutting into the ground a little bit, or we're lifting it a bit higher than the ground, where we're having to put a little bit of fill in as well. Just to be clear, we're talking about where they scrape away the topsoil, and we're talking about the cut and fill relative to the clay side of things. May not be clay, it could be rock, which is even more expensive. So what I'm going to do is I'm going to do a typical design here, a fairly easy one, and then I'm going to throw you loose on an AutoCAD file with some contours on it and a platform, and I'm going to give you a chance to have a go at doing it yourself. But of course, like everything else in engineering, I should have been a baseball player because I love throwing curveballs. Okay, we're going to throw a curveball at you as well. And then I will show you the answer both in AutoCAD format as well as a 3D file that I've made up to try and give you a bit of an idea of what's going on. So you can spin it around and have a look at it, not just in plan view. You're going to have to do platform design for your assignment. So I'm looking at the camera right now. This is 6 or 7 marks that I am not going to give you any help with, and neither will the past students. But because this is being filmed, you'll get a very good idea of the type of things that need to be on the drawing. All right? It's assignment 2, so a lot of you go, oh, not worried about that, that's 5 or 6 weeks ago away. It will come pretty quickly, and you'll be like racing back to have a look at that movie file to see what I've put on the board, okay? So it's not like I'm not giving you the answer, it's just that I'm not going to, when students email me saying, shall I put the word cut on the cut area? I'll say, I'm sorry, I'm not giving you any help with that side of it, but you'll notice tonight I will put the word cut in the cut area, all right? So, Douglas, you should really be putting this file somewhere where you can charge for people to go on the site. Because most of the students I'm noticing are not note takers anymore. COVID's killed your note taking ability. You sit there and you go, oh, I'll watch the video later on. Once again, the video's on an angle, it may be a little bit difficult to see the board, so you will have to listen to what I'm saying. I'm loath to do this, but I'm going to go and turn that off. So how the heck does that go back up again? I'll have to go system off, I suppose. Yep. Right. It may be a little bit difficult to see from the back. Don't worry, I'll leave this on the board. You can afterwards if you want to. And some of the stuff that I'm going to talk about, I'll kind of use quite a bit of the board up while I'm doing it. Okay, so we have a platform. Oh, let's start with a slope down a hill. Let's pretend that that's the slope of grass over there that goes up to the Concentrics building at the top, or the gym. That's where you go, or the squash courts up the top there. And we've decided we're going to, just for example, put a tennis court there or something like that. So we have decided to put the tennis court there. And we are going to have obviously some sort of cut into the hill. That'll be the cut bit. And there'll be also the fill bit as well. And good engineering design would end up with the two areas as best as possible, balancing each other. One of the things about Auckland which makes it really hard to do that is that the Auckland clay, generally speaking, this is very general, has needs to be at a slope of 2 to 1 when it's filled, and it can go right up to about 1 to 1 with cut. Now obviously to save money and time, you're not going to make the cut 2 to 1, you're going to, or else you'll end up cutting more of the bank, so you're going to keep that cut to the minimum, and so therefore it is very difficult to balance cut and fill in Auckland. Generally speaking, you're going to end up with more fill than you are cut, which means unfortunately bringing in, for most sites, clean engineering fill, which means going to a quarry. There's only certain places you can get it around Auckland, and we all know what the traffic's like. Send a truck away at 1 o'clock to get some clean fill, and they come back at 5. You know, the building industry, everybody's got the same issue. So the truck driver's not going to lose money, so he puts his costs up. Everything costs money. The best designs, that equals that, then you're just playing with it on the side, aren't you? Just manoeuvring it around. Or you find somewhere on the site to put it. Generally speaking, environmental engineers don't get too upset if the material that you're digging out of the site is still kept on the site, because you're not taking anything, you're not bringing anything in from another part. Where they get upset is when you bring fill that's not clean engineering fill, and it's come from some other site down the road, and no one knows whether it's full of garbage, trash, you know, contaminated stuff, whatever. Obviously that's not good. Also, it'll end up flowing down into the streams and the water as well. That's another issue. These numbers here are determined by the geotechnical engineer, which I might have alluded to in the first lecture. Normally not a designer's best friend, normally, because they tend to change these numbers, even by a little bit, will mean that whatever you've worked out is going to be completely different again. It's worse on a road. Platform's kind of limited, but on a road, you might be going over 10 kilometres, and if they change these numbers on your batter slopes off the road, your cut and fill balance just goes haywire, okay? So you have to raise the road or lower the road or whatever to try and balance it, which stuffs up your vertical curves. You can get away by putting a different horizontal curve to make the road longer or whatever in an area of cut to balance it out, or fill to balance it out. There are ways around it, but it's the last thing you want to be doing is changing your design about a day before it goes out the door, put it that way, because you might have 50 sheets of sections and 10 sheets of long sections, and you've got to redo them all just because this guy here's changed that to 1.5 to 1 or 2.5 to 1 or something like that, right? So I've tried over the times to buddy up to them and say, hey, you know, a week before, is that final? Oh yeah, it should be all right. And then the day before, oh, I'm doing this because most of them have got a worse beard than me. It's sort of a big beard here like this, you know, they're covered in clay and mud and stuff like that because that's what they do. They'll drill holes and look at soil all day. And they'll just come up the day before and say, look, sorry, I've changed my mind. And usually the word sorry doesn't come into it, it'll be 2.5 to 1. But getting back to what you're doing, this here is design, and this is what we have to do, show in plan view looking down on it. So looking down on our platform here, we have the platform shape, which is easy to do, that's not a problem. Where this meets here and on the other side will be the area of cut, and you'll find that the area of fill, because this is normally, I've not quite drawn that right, it's normally sort of something like this, so it ends up being quite a bit bigger, and so the area of fill sort of ends up, it can be as big as that sort of thing, right? And you're starting to see what I mean by butterfly wings? All right, this one's flying into the sun, so it's like this, all right? Yeah, it's a bit weird because I've taught 2,500 students over the years, and they all refer to that as butterfly wings, which is totally not an engineering term. They are actually called top of cut, and anyone know what that one's called?
Bottom of the fill.
The bottom of the fill. Who said that first? Congratulations, you're not getting half a mark. They're called the toe of the fill. It's all right, you get a chance in about week 8, sequel. Roger Gibb, horrible lecturer, does not give out half marks very easily. Yeah, the toe of the fill. If you've done, now see, you guys are pretty, guys and girls, most of you have done 4 subjects here at Unitec in semester 1. 1 or 2 have done a few more. If you've done the likes of Geology 1 or something like that, you would be, if there's a slip in geology, they refer to the bottom of the slip as the toe of the slip, right? So in engineering, we refer to anything at the bottom as, you'll always remember that, won't you? It's one of my questions in the test.
Oh, is it?
Yeah, you'll be the only one that gets that right. So they have a name, so don't call them the butterfly wing just yet. Wait till you get into industry and see the reaction of your boss. And also the other thing we do with this is we need to see which way, when you're looking at a plan view of this, you want to see which way it's sloping. So we always put these little batter slope things, which I introduced you to last week, but said I'll tell you more about them this week. They look sort of something like this. And we always put them at the top of the slope. So we'll put one there, and we'll also put one there going downwards. So they'll go like this. A lot of students put them in the wrong place. Always at the top. They're called, for want of a better word, these are called batter slope symbols. Now, you won't need to put them on your existing site plan because that's an existing site plan, but you will need to put that as a little extra on your legend of your assignment 2. Okay, so that's the basic principle of what I'm about to design on the other side here. What is the tricky bit is working out how much in horizontal we go for every vertical that we go up 1 meter. And I'm using some pretty easy numbers. Believe me, it gets more difficult when it's the likes of 2.3 to 1.1 or something like that, okay? So I'm going to design, I'm going to just show you how we do kind of something like that area there. So there's a wee bit of cut and there's a little bit of fill. And more precisely, I'm going to show you how we find this line here. This line is where the all your engineering work hits the existing ground, right? So kind of that point there as it goes around in plan view. So let's do an example of a platform, and let's call this 20.0 as the platform level, okay? And let's do some contours through it. I'm just hanging out here with my contours mates. There's 20, 21, 22, 23, might even do a 24. We'll put the numbers here: 24, 23, 22, 21, 20, 19, 18, 17, right? The next step is to, well, you'll be in AutoCAD, so you know how much a metre is and how much 2 metres is, how much 3 is. To demonstrate this, I'll have to do what you're going to be doing on your locality plan, which is one of these things. So let's just put a little scale bar on here: 0, 1, 2, 3, 4, 5, etc. So the first thing to identify on any platform design is the area that is cut and the area that is filled. The simplest way to do it is to look at these numbers and to look at that number. These numbers are higher, so it's the cut. It's as simple as that, okay? These numbers down here are lower, so this area down here is going to be the fill. Very important to identify that. And look, I have no problem with you leaving cut and fill on your design platform. I think it's a very good idea. Don't have a problem with that. You can call it fill area or cut area, or you can just leave it in that particular side. So let's do the cut first, because the cut's easy. It's 1 to 1. That means that for every time we go this way 1, we go up 1, this way 1, up 1, this way 1, up 1. So looking down is very simple. We're offsetting from the platform 1. So let's offset from the platform 1. We'll do that in blue. Here's 1, there, there. We only need to do it on the cut side. Alright. I better put some numbers beside these. So that will be going uphill, that'll be 21, 22, 23, and 24. And now we go, and where the 21 hits the 21, which is there, we put a cross. Where the 22 hits the 22, another cross, 23 and 24. We join up those crosses, and that is our, you've forgotten already, top of cut. Top of cut. But now, for those that try to do this on your assignment, this is really important. I'm looking at the camera. You can't cut through that line to go to that point. You must go around here to get to that point, all right? You must stay between those two lines there. Otherwise, you're cutting through the 21, then going back to the 21. And now the last point is going to be this point here, which is equal to the 20 contour going through the platform. Because technically there's no cut or fill at that point. So we'll go around and we'll go to the other. Now a lot of students just do that and they think they hand it in and they go, whoopee, Roger's going to give me a good mark, I've done it, I've done the calcs, done the hard work. Whereas you might as well put that on your grandmother's fridge magnet because it's not a proper design drawing. It's just a whole lot of lines everywhere, right? You've got to tidy that up. So what I expect you to do is to change that line from there to there to a layer called Contour 21 Delete. And I don't want to see it. I want you to freeze it. So that'll go. We'll, just for the record, we'll put him out here and put 21. 22 out here. 23, you'll see why in a minute. 24. This one will go, but it'll stop at that point there where it hits the ground. This one will go and it'll stop at that point there where it hits, and that one will stop where it hits. Now, these design contours are the same. We don't need them over there, and we don't need them outside of the batted, so that 23 is going to have to go inside. And the 24 is going to have to go there as well, because that will disappear. Gone. I always go home after this class with lots and lots of ink all over me. Go and touch something I'm not supposed to touch. Okay, so there we are. That's what that will look like. This is only this little bit going around here. This will carry on. Of course, it'll go right around the platform to the other side, and then it'll hit over here somewhere. And what we need to do with this piece here is we make up a line type, like 2 dashes and 2 wee ones, or 2 wee ones and a big dash, or something like that. And this is called our line of equal cut and fill. So on this job here, it represents that point. And when the surveyors set it out, they generally put a peg on that point, because the digger should not touch it. They should not take any dirt away or clay away. They should not put any clay where that peg is, because it should be basically almost the exact ground left there. It's best to keep the contours on a layer, so you have to split, and one would be frozen, and one, so you might have to call it contour layer freeze and contour layer normal, or 21 or 18 or 17 or whatever. So the only one that you would do would be this one, which you would change to the line of equal cut and fill. That's okay, as long as it's a logical name. Okay? Not layer 1, layer 2, layer 3, all right? You've got that was last semester. So how do we do the fill? Well, when you're looking at fill, it's a bit different. We go along 2, up 1, along 2, up 1, along 2, up 1. So therefore, this time we're going to go off by 2. So this time, instead of 1, we're going to go off by 2, which is about that. And of course, this is going to be 19, 18, and 17. Yeah, along 2, down 1, 2, 1, 2, 1, 1, 1, 1, 1, 1, 1. So putting the crosses in. So that would be the big side of the butterfly wing that would go right round and also end up back here. I'd love to show you exactly where it went, but I'd probably get in trouble with Unitec for drawing all over their walls. But you get the general idea of what's going on. Once again, this will disappear all the way down to that point there, and at that point there, the 18 will be here, the 19 will be there, that will be up to there, that'll be the 20, and that'll be the 17. And these disappear as well.
And if you put contours on, is it okay to use the same layer as the contours that we've given, like survey, or do you want to?
No, yeah, definitely put them on a different layer.
Yeah.
These are called design contours
Design contours.
or formation contours, either or, is correct.
So I mean,
Okay.
the assignment one, not assignment two.
Assignment 1, you won't have any formation contours on there at all. Assignment 1 will just be,
When we do our contours, you know how we would get spotlights and we put contours with them?
yep,
Should we put them on the same layer?
as the other ones that I've got there, as long as it's a layer called contours, that's fine. Some students like to break it down to contour 20, contour 19, contour 18. That's fine as well. Depends how much you want to break it down to and how many layers you want to end up having. I kind of feel that in most cases there's no harm in as many layers as you can, because from my experience, if you try to keep your layers to a minimal, you're going to get a client come in and say, oh, can I please have just the buildings, the paths, and I'd like those trees there but not those ones, and can you also send me the spotlights and everything else turned off? And you're like, whoa, I've actually put the path on the same layer as the building, and that tree's on the same layer as those trees over there. How am I going to do this? Because normally you just turn them on and off on your layers and do a print, wouldn't you? You know? So that is the power of AutoCAD, is turning those layers on and off and then doing a completely different drawing for another person. You do it real quick. So I've always said to my guys that have been doing the drawings, hey, you know, the more layers, the better, as long as they make sense. Surveys don't tend to give you layers that make sense. You know, they'll go LLPZ1, and you're like, to them it might be the level of the intersection, you know. So it might be lit level INT1 or something like that. And you, as an engineer, sitting there, what the heck's that, right? For some reason, maybe they take joy in that. Maybe they think that we live just to try and interpret their surveying. It's a tricky world out there. The surveyors from office to office, some of them will come in and they'll say, guys, we're doing the survey for you. What are your layers? What do you want everything on? Which is what it should be. And they'll come back and they'll produce a lovely drawing with all the layers ready for you to start work on. Others will just come back with random layers and they'll say that's the way we do it. You picked us for the cheapest survey. Now you're in trouble. And yeah, there's many a time that we've been spent a whole day fixing a survey up just to get it ready to do design drawings on. So I said to you before, I'm going to throw a curveball, right? And it wouldn't be engineering without a curveball, really. Let's have a look at the next one in line. Let's have a look at number 2, which is, of course, that's turning these on and off all day. So